completed the preparation of alkanes. Now let us start the chemical reactions of alkane. So we have solved the MCQ questions also. Every preparation we have solved 3 to 4 questions. So at your home you solve all the MCQ of chemical preparations of alkane. Okay, then if any doubt, you will get any doubt, you can ask to me. Okay, so therefore we will start. So next part of this topic, that is very important part, that the chemical reactions of alkane. Okay, so this is the third part or fourth part, that is the chemical reactions of alkane. So you know that in 10th class you have studied the reactions. So actually what is the chemical reaction? So chemical reaction is nothing but the breaking of one bond and formation of new bond. That is the chemical reaction, right? Okay, so there are different chemical reaction you have studied in the 10th class already. What are that reactions? So decomposition reaction you have studied, displacement reaction you have studied, addition reaction you have studied, right? So these type of reactions you have studied in the 10th class. So next reactions type we will see in the alkane topic as well as alkene alkyne topic, right? Okay, so chemical reactions of alkane. First reaction of alkane is the halogenation reaction. Okay, so this is the halogenation reaction. Okay, this reaction we have to study in this topic. What is meant by halogenation reaction, how it is occur, that examples and their definition we will see. For example, suppose I have, this is the RH, this is the representative formula of alkane. This is the representative formula of alkane. So that is the paraffin. Okay, so this is the alkane or the paraffin. So when this alkane is heated with the halogen, okay, so X2, that is the halogen. When this alkane is heated with the halogen in the presence of suitable catalyst, right? Okay, heat it. Okay, what is the general reaction? That we will see, and then how halogenation is to be defined. So when this alkane is heated with the halogen, so you know that this halogen is X2. So halogen may be chlorine Cl2, bromine Br2, iodine I2, fluorine F2, right? So this is in the form of molecule. So this chlorine, bromine, iodine, fluorine, combinedly they are called as halogens, right? Okay, so this halogen X2, so X2 may be chlorine, bromine, iodine or fluorine, right? So how this reaction takes place? So when this alkane is heated with halogen in the presence of suitable catalyst, different catalyst for different halogenation reaction, right? Okay, so what are the suitable catalysts? We will see one by one for each and every halogenation reaction. So when this alkane is heated with this halogen, what happens? This hydrogen molecule is this hydrogen atom is replaced. This hydrogen atom is replaced by the halogen atom. So what you will get? You will get the Rx plus Hx is the byproduct. Okay, so you know that what is meant by Rx? That is the alkyl halide. Okay, Rx is the alkyl halide common name, and IUPAC name is haloalkane. Common name is alkyl halide, IUPAC name is haloalkane, right? Okay, so this is the general reaction. Now what is meant by halogenation reaction? See, the reaction which involve the replacement of hydrogen atom, that may be one hydrogen atom, 2 or 3. Okay, so therefore the reaction which involve the replacement of one or more hydrogen atom of alkane by same number of halogen atom is known as halogenation of alkane. Okay, What is meant by halogenation of alkane? The reaction which involve the replacement or substitution. Okay. The reaction which involve the replacement of one or more hydrogen atom of an alkane. Whose hydrogen is to be replaced? Alkane's hydrogen is to be replaced. The reaction which involve the replacement of one or more hydrogen atom of alkane by same number of halogen atom is known as halogenation reaction. That is the halogenation of alkane. So what is the halogenation of alkane? We are going to replace the hydrogen from the alkane and we are added the halogen to the alkane. So therefore it is called as halogenation of alkane. The reaction which involve the replacement of one or more hydrogen atom of alkane by same number of halogen atom is called as halogenation of alkane. Okay, so this is the definition of halogenation of alkane. So halogenation of alkane are of 4 types. What are that? First is chlorination of alkane. Chlorination of alkane. This is the first type. So second type is bromination of alkane. Bromination of alkane. Third is, that is iodination of alkane. Iodination of alkane. And fourth is fluorination of alkane. Fluorination of alkane. These are the 4 types. So first is chlorination of alkane, second is bromination of alkane, third is iodination of alkane, fourth is fluorination of alkane. So these are the 4 types of halogenation of alkane. Right? Okay. So we will see one by one. Right? Okay. So first of all, we will see the chlorination of alkane. So first of all, chlorination of alkane. Okay. So what is meant by chlorination of alkane, and then how the reaction is to be carried out, that we will see detail. So first is the chlorination of alkane. Chlorination of alkane. So what is the chlorination of alkane? See, general reaction, we will see the general reaction. So when this alkane is heated with the chlorine, now chlorination, chlorine. So this is the chlorine molecule. Okay, so this is in the form of gas. Chlorine is generally in the form of gas. So gaseous form of chlorine is to be reacted. So when this alkane is heated with the chlorine in the presence of ultraviolet light. See, this is the catalyst. So in the general reaction we have seen the suitable catalyst. So what are the suitable catalysts? Ultraviolet light or diffused sunlight or AlCl3 catalyst. So these are the different catalysts. So suitable catalyst for chlorination of alkane is ultraviolet light. So you know that ultraviolet light, so ultraviolet light is the catalyst used in the chlorination or diffused sunlight. Sometime the word used is diffused sunlight. So what is the diffused sunlight? So the light rays vibrate in all the direction. The light rays vibrate in all the direction is called as diffused sunlight. Right? Okay. What is meant by diffused sunlight? The light rays vibrate in all the direction. That is called as the diffused sunlight. So when this alkane is heated with the chlorine in the presence of diffused sunlight or ultraviolet light, then what will happen? Hydrogen atom of alkane has been replaced by the chlorine. So this is the replacement reaction. That is the substitution reaction. So here what we have replaced? Hydrogen we have replaced. What we have substitute? Hydrogen we have substitute. What we have added? Chlorine is added. So therefore replacement of hydrogen, substitution of hydrogen by the chlorine. right? Okay, so when this alkane is heated with chlorine in the presence of suitable catalyst, that is the ultraviolet light or diffuse sunlight, so hydrogen atom is replaced by the chlorine, so that is the RCl. So this is called as alkyl chloride, or it is also called as chloroalkane, right? So this is the alkyl chloride or chloroalkane, right? So this is the general reaction. So what is meant by chlorination of alkane? The reaction which involve the replacement of one or more hydrogen atom of alkane, one or two or three or more than three may be replaced. So therefore the reaction which involve the replacement of one or more hydrogen atom of alkane by same number of chlorine atom is called as chlorination of alkane. What is meant by chlorination of alkane? The reaction which involve the replacement of one or more hydrogen atom of an alkane by same number of chlorine atom is called as chlorination of alkane. So have you understood what is meant by chlorination of alkane? Okay, so again I will repeat, the reaction which involve the replacement of one or more hydrogen atom of an alkane by same number of chlorine atom is called as chlorination of alkane, right? Okay, so this is the definition, this is the general reaction. So chlorination of alkane can be carried out by two ways. Okay, chlorination of alkane can be carried out by two ways. What are that ways and what is the example, that we will see detail. Okay, so first of all let us take the example. Okay, so example is methane. So this is the first alkane member is methane. So you know that in the 10th class also, or in this first topic that already you have been completed, that is the general organic chemistry. So in that topic you have seen the first member of the alkane is methane. So that is called as the marsh gas. So this is the methane. When this methane is heated with chlorine, okay, so this is the chlorine. So we have taken the chlorine as a excess. What we have taken? Excess of chlorine. Excess means large amount of chlorine. What is meant by excess? More amount of chlorine or large amount of chlorine. Okay, so therefore when this methane is heated with chlorine in the presence of UV light, so instead of UV light, sometime this should be written like this also. In some book, instead of this ultraviolet light, that is the H mu photons. Okay, H mu. Okay, so H mu indicate that the ultraviolet light is there or diffuse sunlight is there. In some book, only H mu is written, that is the packet of bundle of photons. H mu indicate packet of bundles of photons. So this is the H mu, right? Okay, so heat it. Okay, so what is the substrate? Substrate is methane. What is the reagent? Reagent is chlorine. Okay, in the chemical reaction, substrate is there, reagent is there, product and byproduct, that is the chemical reaction. Okay, so this is the methane. When this methane is heated with chlorine, what is the type of this reaction? Substitution reaction, replacement reaction. What is to be replaced? One or more hydrogen is to be replaced. So therefore in this first reaction, this one hydrogen atom is replaced by chlorine. So what you will have? You will have, so this is CH3 is as it is. This hydrogen is replaced by this chlorine, right? Okay, then this H and this Cl, they comes out in the form of HCl, right? So this is called as methyl chloride. This is called as methyl chloride, or it is also called as chloromethane. This is called as methyl chloride or chloromethane, right? Okay, so as we have seen that this chlorine is excess, due to this excess of chlorine is taken in the chemical reaction, reaction does not stop unless and until all the hydrogen atom is not to be replaced. Reaction is not stop, reaction will not stop. Why? Because we are taken here as excess of chlorine. Okay, so we have taken here excess of chlorine. So therefore, if the excess of chlorine is taken, all the hydrogen atom is not to be replaced, reaction will not stop. So therefore, this is the first step. Again this methyl chloride. Okay, so again this methyl chloride is reacted with the another molecule of chlorine. So H mu, heat, right? Okay, so second hydrogen atom is replaced by the chlorine, because we have taken the excess of chlorine, large amount of chlorine, excess of chlorine, higher amount of chlorine. So therefore this hydrogen atom is to be replaced. So what you will get? You will get so this compound. This is called as methylene dichloride. This is called as commonly methylene dichloride. Okay, or it is also called as 1,1-dichloromethane. Right, this is called as 1,1-dichloromethane. This is the IUPAC name, right? Okay, 1,1-dichloromethane. So this is the one carbon, two chlorine are there, one for this chlorine, this one for this chlorine, 1,1. Two chlorine, di. Chlorine is there, chloro. One carbon is there, methane. So therefore this is the IUPAC name, 1,1-dichloromethane. This is the second step. Now in the third step, what happened in the third step? So this is the chlorine, this is the hydrogen, this is the chlorine. So this methylene dichloride again react with the chlorine, because already at the outset I have told you that unless and until all the hydrogen atom is not to be replaced, reaction will not stop. Okay, so therefore this is the third molecule of chlorine. So this hydrogen atom is replaced by the chlorine again. So therefore this is the ultraviolet light, that is the pocket of bundle of photons, H mu. Okay, so therefore this hydrogen is replaced. What you will have? You will have, so this is the hydrogen, so this is again chlorine, right, plus HCl. Okay, so therefore what is the name of this compound? This is called as chloroform. What is the name of this compound? Chloroform. That is IUPAC name. This is the one carbon. At this one carbon, how many chlorine are there? 3. So therefore 1, 1, 1. 3 chlorine. Tri, name is chloro. Then this is the methane. Right? Okay, chloroform 1, 1, 1, trichloromethane. Right? So this is the third step. Still one hydrogen atom is remain, isn't it? So here only one hydrogen is remain. So therefore this hydrogen is also get replaced. Okay, so therefore I will write here. So this fourth step I will write here. Right? Okay. So what is the fourth step? So we have the chloroform. Right? We have this chloroform. So this is the chloroform. So these chlorine atoms are there, plus this chlorine in the presence of ultraviolet light. You can write the H mu also, or you can write the UV light, ultraviolet light, heat it. Right? Okay. So what will happen? So this hydrogen atom is to be replaced. Right? Okay. So therefore this hydrogen is replaced. So what you will get? You will get, so this is the chlorine, this is the chlorine and chlorine. Okay. So plus HCl. So here there is no any hydrogen atom is remain. So hence reaction stop here. Okay, because all the hydrogen atom is to be replaced here. So therefore no more hydrogen is present here. So reaction stop here. So this is called as the chain reaction. This reaction is also called as the photochemical reaction or chain reaction. This reaction is also called as photochemical reaction. Why it is called as photochemical reaction? The chemical reaction is carried out with the help of photons. So that is called as the photochemical reaction. This reaction is also called as the chain reaction. This reaction is also called as the chain reaction. Why this is called as the chain reaction? Because first of all, methyl chloride is produced. Then this methyl chloride again react to form the methylene dichloride. Methylene dichloride again react to form the chloroform. Chloroform again react to form the carbon tetrachloride. This is called as the carbon tetrachloride. Okay, so 4 chlorine atoms are there. So 1, 1, 1, 1 tetrachloromethane. This is called as 1, 1, 1, 1 tetrachloromethane. This is the final product. Okay, so why this is the chain reaction? Because number of products are produced in the reaction. 4 products are produced. So chain reaction takes place. One is formed, second, third, fourth. So therefore this is also called as the chain reaction. Okay. So now what is the product? How many products are there? 4 products are there. So when the excess of chlorine is reacted with the methane, mixture of 4 products are produced, and that mixture of 4 products are methyl chloride, methylene dichloride, chloroform and carbon tetrachloride. These are the 4 products. When these 4 products are produced, if methane is reacted with the excess of chlorine, but if excess of methane is taken, you will get the only one product. So here the 4 products are there, polychlorinated product. So 4 products are there, so therefore it is a polychlorinated product. When polychlorinated product is produced, if excess of chlorine is taken. But if the excess of methane is taken, you will get the only one product, that is the monochlorinated product. Right, that we will see. Okay, so this is the first way to carry out the chlorination. So keep in mind, when methane is heated with the excess of chlorine in the presence of UV light, mixture of 4 products are produced. Okay, this you have to keep in mind. Second way to carry out the chlorination of alkane. So what is the second way? See, I will tell you how the second way is there. So what is the second way? So second way is when excess of methane. When excess of methane is taken. Excess of methane. So instead of excess of chlorine, what we are going to take? Excess of methane. So when the excess of methane is heated with the chlorine in the presence of ultraviolet light, you will get only one product. You will get only one product. So what is the one product? Methyl chloride, chloromethane. Okay, but if the excess of chlorine is heated with the methane, you will have the 4 product, that is the methyl chloride, methylene dichloride, chloroform and carbon tetrachloride. And just now we have seen. But when the excess of methane is taken, you will get the only one product, that is the monosubstituted product. Monochlorinated product. What is the monochlorinated product or monosubstituted product? So this methyl chloride or chloromethane is the monosubstituted product. Right? Have you understood what is the polychlorinated product and monochlorinated product? So this is the 2 way to carry out the chlorination of alkane. So another example of this type we will take. So generally we have to take the second type of reaction, that is the when excess of methane is heated with the chlorine. Okay, so next reaction, when the excess of ethane. Okay, so this is the excess of ethane. So when the excess of ethane is heated with the chlorine in the presence of ultraviolet light as a catalyst, heat it. Okay, then what will happen? Only one hydrogen is to be replaced. Okay, we cannot replace the number of hydrogen atom here. Why? Because we have taken excess of methane, ethane here. We have not taken the excess of chlorine here. If the excess of chlorine is there, all the hydrogen atom is to be replaced. But if the excess of ethane is there, then only one chlorine atom is to be, only one hydrogen atom is to be replaced. So therefore, this is the replacement reaction. So this hydrogen atom is replaced by the chlorine. Okay, so therefore, what you will get? You will get CH3, CH2, Cl. Hydrogen atom is replaced by the chlorine. This CH and this Cl, they comes out in the form of HCl. Right? Okay. So this is called as ethyl chloride. This is called as ethyl chloride. So what is the rule for common name system? First write the name of the alkyl group and then put the word halide. So name of the alkyl group is, this is ethyl. Word halide is chloride. Bromine is bromide. Iodine is iodide. Fluorine is fluoride. So therefore, this is called as ethyl chloride, common name. IUPAC name, first write the name of the functional group. Name of the functional group is chloro. As you know that this X is the halo functional group. And I have seen the functional group and their types. So this the X is the halo, this is the chloro, bromo, iodo, fluoro, name of the functional group. So therefore, in the IUPAC system, first write the name of the functional group chloro, then count the total number of carbon atom in the chain. Total number of carbon atom in the chain 2. So therefore, if the 2 carbon atoms are there, what will be the alkane? So parent IUPAC name of alkane is ethane. So therefore, name will be chloroethane. Okay, similarly, suppose I have the next example, that is the propane. Right? Okay, so this is the propane, right? When this excess of propane, we have to take the excess. Okay, so therefore, if the excess of propane is taken, okay, then when this excess of propane is heated with the chlorine, okay, in the presence of ultraviolet light, right? When the excess of propane is heated with the ultraviolet light, okay, then what will happen? So if the example is like this, you should know the one hint. What is that hint? The order of replacement of hydrogen is tertiary hydrogen atom is easily replaced than the secondary hydrogen atom than that of the primary hydrogen atom. So this is the order of replacement of hydrogen atom, right? Okay, what is the order? Tertiary hydrogen atom is very fastly replaced than that of the secondary hydrogen, than that of the primary hydrogen. So you observe here, this is the secondary carbon. Why is the secondary carbon? The carbon atom which is attached to 2 other carbon atoms, so therefore this is the secondary carbon. Attached hydrogen atoms are secondary hydrogen. This is the primary carbon atom. So primary carbon, attached hydrogen, primary hydrogen. What we have? We have the order of replacement of hydrogen atom. What is the order of replacement of hydrogen atom? Tertiary hydrogen easily replaced than the secondary than that of the primary. So therefore, which hydrogen atom easily replaced? This secondary hydrogen atom is easily replaced. So this is the secondary hydrogen atom is easily replaced. So therefore, this is the CH3. So this is the Cl. This is the hydrogen, and this is the CH3. Right? Okay. So what is the name of this compound? So you know that this group is called as the isopropyl group. So therefore, this is called as isopropyl chloride or secondary propyl chloride, or it is also called as 1,2,3,2-chloropropane plus HCl. Right? Okay. So this is the third example. So excess of propane gives isopropyl chloride. So to solve this problem, you should know this order: tertiary hydrogen, than secondary, than primary. Okay. So next example we will see in the next video.